You're about to listen to the Complete Developer Podcast, the podcast by coders and for coders about all aspects of life as a developer.
I'm Will, the curmudgeonly experienced developer.
And I'm Beej, the optimistic newbie developer. Welcome to another episode of the Complete Developer Podcast. Before we get started, Will, what have you been fighting this week?
Well, I have been fighting with obfuscated JavaScript. We have a HTML editing component that is in a product that is yet to be released when I'm working. And we paid for the $500 license.
Yeah. And
it turns out there's a few issues and we can't really figure out what they are. And we could pay for the full source code, and I think they may eventually do that, but the full source code is like $8,000.
Oh, wow.
So while that's getting sorted out, I still have to make forward progress. And it turns out that they obfuscated the JavaScript code in such a way as to make it where you can't really follow what's going on client side, and I'm doing that anyway.
Nice.
And I've gone through and I've found a couple of things where some of our assumptions were not correct, because I was able to basically get the Chrome debugger up and look at variables as we're stepping through, and the variables all have hexadecimal names. There's no useful names at all. That's the way they obfuscated it. But it turns out that I can still take that variable, and using the console, I can actually see its members and its properties, and I can tell, okay, that's what this is, and then I write that down, and then I see what they're doing to it, and I write that down, and I've been able to walk my way through and find some things. So it's been pretty ugly. Not a fan of having to troubleshoot this sort of stuff at all.
I don't think anybody would be.
Yeah, I mean it's
except for people that like CSS.
Well, it's not even like CSS. I mean it's
No. I'm just saying the masochistic people that like CSS.
Yeah. So it's definitely been a bit of a painful journey, and I showed some of the other developers that I'm working with what I was doing, and I think their reaction is what told me that it really wasn't okay.
Wow.
Because I tend to just, if something gets in my way, I tend to drive straight through it anyway, if I possibly can. And this was very difficult. It's like, it was like cleaning up assembler code and having to know the different opcodes and all that. It was just really ugly.
Sounds like something you would just barrel right on through.
Well,
because that's the way you are.
Well, the thing is I thought that I could fix the one problem that I was having, and I was like, well, let's just get this done and not spend $8,000.
Yeah.
And then when I fixed that, it turns out that there were some other things, and so I thought, well, I'll fix those. And so it just became this snowball of digging through obfuscated JavaScript code. And supposedly we're going to actually get a new updated license tomorrow, and I actually get to see the real JavaScript code that I've been debugging all this time.
Fun.
With actual variable names, which will be cool. So what's going on with you?
Nothing quite that interesting. I've been doing some kind of pseudocode questions for that companies ask when you interview with them, like pseudocode interview questions.
Those are always so much fun.
Actually, they kind of were. I mean, I like that kind of stuff. I would do that for fun. Actually, on one of them, it asked for feedback at the end of the set of questions, and my feedback was, that was fun. Can I do more? And it's one of those things where I know I got all the answers right, except for the last one, and it was kind of a regex question.
But it wasn't regex. You were telling me about that.
Yeah, I told you about that earlier. It was crazy, and
just for the people out there, I'm terrible at regex. I've been programming professionally 12 years and some change, full time. Plus, I did some in college, and my approach to regexes has been to always make sure that it's somebody else's problem.
Well, see, up until that last question, I think the last 3 or 4 questions in that set were regex questions. And those, I know I got the right answer. I could sit down and do a proof on why that was the right answer. The last one, I chose the answer because I could prove all of the other ones wrong. I still don't know why that was the right answer.
It's a valid test-taking strategy.
It is. It's frustrating for me because that strategy doesn't work in medical school. at all. And
it doesn't work in real life either.
Yeah, and so I've gotten that particular strategy out of my head. It took me an extra 5 to 10 minutes just to redo that strategy when I got to the end of the question, and I'm like, I'm not really sure on this one because it doesn't really make sense.
I mean, regex is very helpful. I like simple, regular expressions, but I mean, even if you have a regex to validate, say, a telephone number, it's awful. You just look at it, and it looks like line noise.
Yeah.
Which is why you find a Perl programmer to help you with it, because they're used to that. I've got several friends that are really, really good at regex, and they can throw one up on the page that's as long as your arm, and they're fine.
See, like I said, I found it really fun up until that last one, which makes me kind of wonder if possibly that none of the answer options were correct, and it was just testing to see if I would pick the one that was the best, because there wasn't none of the above. There was a question earlier that when I looked at it, I was like, well, none of those answers are right, and then at the bottom it had none of the above.
So, I guess you said it was pseudocode. Like,
Mm-hmm.
did it get into object-oriented stuff, or was it just, like arrays and loops? And
The arrays and loops and stuff, so it didn't get too far into that. There was, kind of started off like, it started off like a Algebra 2 quiz. Like, Algebra 2 word questions.
Oh, yeah.
I pulled out a notebook and started writing stuff down, because I had to create equations, and then the most fun one for me was the while loops. The first question about them was just a regular while loop, and then the second one was a nested while loop, and you had to go through the whole thing and then show what the output would be.
Well, I remember doing those back in school, and yeah, the tying them to Algebra 2 word questions is it's actually pretty apt. Of course, there's always the thing where you get like you get the answer that's not the answer that they're looking for, and you have to kind of shake your head and go, okay, they want a technically correct answer. Like, I'll give you an example, say, Johnny has a dozen donuts, and Johnny eats 10 donuts. How many donuts does Johnny have left? Or what does Johnny have?
Diabetes.
Exactly. And I always think of things like that on those kind of questions, so it's not really good for me.
Yeah, this one, I guess you could have entered that, but the questions were worded so that really wouldn't, nothing like that came to mind, and I think like that too. I did like how on those questions it wasn't multiple choice. You had to enter in the number.
I mean, I guess that helps. For questions like that, really my thought is the correct answer is to find a library that does it, or do it in a clearer manner, not sit there and spin on it. Because when you spin on it and you write it that way, somebody else has to clean it up that way when there's a bug.
Well, my attitude is, at my level, it's like...
It's a good thinking problem, but it's kind of common even if you take the Microsoft exams. Sometimes they'll throw stuff out there. It's like, okay, that's technically the correct answer, but that answer will get you fired.
Yeah. I mean, the way I look at it, and this is what I was saying, from my education level, where I'm at in my learning, it's like when you learn math, you learn how to do things the long way. Well, before Common Core, you learned how to do things the long way, and then you learn the shortcuts. It's like my calculus teacher once said that calculus wasn't difficult. It was getting the equation to where you could do the calculus, because the calculus was actually a shortcut for very long algebra.
Yes.
With that said, let's go ahead and play that smooth music.
I wouldn't call that smooth.
this week for IoTs, I'm going to do what I promised a couple weeks ago and start talking about programming languages for IoT. And the first one we're going to talk about is C. And we might do a little talk about C++, but I got enough on that, and there's enough interesting stuff about it for its own IoTs. And I want to start by reading something to you guys, to the philosophy of the C and C++ compiler, and this is from learncpp.com, and that is, trust the programmer, which is both wonderful because the compiler will not stand in your way if you're trying to do something unorthodox that makes sense, but it's also dangerous because the compiler will not stand in your way if you're trying to do something that could produce unexpected errors. Basically, what it's saying is with these languages, knowing what you shouldn't do is just as important as knowing what you should. Speaking of C specifically, learning C makes you a better programmer because you're forced to deal with these issues earlier and more frequently. The C programming language is a structure-oriented, mid-level language, though I have heard some people say it was a low-level language.
But it changes over time.
Yeah.
Perception changes, because it was a high-level language when it came out.
No, well, that makes sense, yeah.
So it's kind of like depreciation or something.
Mm-hmm. Just a little history on it. It was developed at Bell Laboratories back in 1972 by Dennis Ritchie, and it was derived from an earlier language. And can anybody guess what that was?
Java? Sorry, no, not really.
If it's C, it was derived from B.
Yep.
Some of the features of the C language are reliability, portability, flexibility, interactivity, modularity, and that's the degree to which the system's components can be separated and recombined. It's also very efficient and very effective. The C language is used for developing system applications that form major portions of operating systems, such as Windows, Unix, and Linux.
Right, and it frequently shows up underlying other languages. There's some pieces that the .NET framework, for instance, relies on that were written in C. Same thing, I think, with some of the JVM pieces. You'll also see C being used, being called out to from other applications or other platforms, I guess is a better way to put it. For instance, you'll see Python call out to C pretty regularly. You'll see that with Ruby and a number of other languages. The other thing I really like about C is that you can inline assembler in it. So if C is just too slow for you for some reason, which doesn't happen often, but it can happen, you can actually put inline assembler in there and get right down to where you can really, really tightly optimize something. It's not done very frequently now, but it can be rather handy.
So, now we've told you a little bit about C. Why is it good for IoT? Well, if you haven't been able to figure that out, because I kind of angled this to show that, but it was invented for implementing Unix operating systems, which it makes it perfect for IoT, especially Raspberry Pi apps, because there's most of the Raspberry Pi operating systems are Linux or Unix based. You'll be able to read and write code for a large number of platforms, everything from microcontrollers to the most advanced scientific systems can be written in C. And as I've stated a couple of times already, a lot of the modern operating systems are written in C. So I want to end with another quote, and this one is from someone we've discussed on the podcast before, which is Zed Shaw from his Learn to Code the Hard Way. The C programming language is giving you access to what is really there and telling you the cold, hard, raw truth. C gives you the red pill. C pulls the curtain back to show you the wizard. C is the truth. Hey guys, I just wanted to take a moment to talk to you all about something that has probably affected every single one of us, if not directly, then someone we love, and that is breast cancer. Will and I are going to be participating in the Susan G. Komen Breast Cancer Walk here in Nashville in a couple of weeks. We are joining the Bippity Boppity Boobies team. Now, we didn't come up with that name. I believe my friend Lucretia did. She's the team captain. So shout out to Lucretia for putting that all together. This is the first year that Will and I have participated in it. So if you want to support us, we will have a link on our website over to the group page at komen.org. The topic for this week is going to be things that developers act like are true, but really aren't. And Will, you want to start us off?
Sure. I guess the first, or point number one here, is that a lot of developers act like it's not a big deal when software fails. And this is actually very apparent pretty much to anybody that uses software. The software is known to crash a lot and break in production a lot. And a lot of people have a fairly flippant attitude about it. It's like, well, if it crashes, we can fix it. And I want to throw a few things out here. First of all, when software crashes frequently, it does cause financial disruption to the company that owns the software. And that may not seem like a huge deal if it's just a small interruption, but over time, those can add up. Eventually, financial disruptions can take a company down. We've seen this with any number of software companies that had products out there. The products got so unstable that they were abandoned. If you consider, well, think about your web browsers. If Microsoft's only product was Internet Explorer, do you think they would still be around?
No, well, yeah, but I just think Internet Explorer would be a whole lot better than it is. Well, than it was. It's getting a lot better.
Yeah,
and if you haven't tried Edge.
I haven't.
Edge is...
I've heard it's really good, but...
It is.
The point here is that if a company has a single product especially, software bugs are not really a good idea to ignore. Because it can disrupt the company, it can break it down. And while we're on the subject, why do we call them bugs? If I recall correctly, the story is because of Admiral Grace Hopper back in the 40s, and she was apparently just really, really awesome, just all around. But there was a computer that literally broke down because a moth flew into it. Now, this may or may not actually be a true story. You'll hear different accounts. Okay, and they said, oh, there's a bug in it. And that term stuck. Sounds great, but that's not what a bug is. What we call bugs in software are defects. Right? You recall a car that has, defects in the braking system because people die if you don't. Software with defects is really a lot more serious than we frequently give it credit. Now, mission control systems, those kind of things, those are usually, people try to get the bugs out of those. Right? But even simple software or even software that shouldn't have life-altering consequences if it breaks can have life-altering consequences. For instance, let's say that you have a Facebook game. Okay, you've got 3 or 4 employees, and your game crashes and has a bunch of bugs and causes problems. And so the users all, unsubscribe en masse, right? What happens next? Well, the bottom line of the company falls down, right? Eventually you have to have layoffs. Okay, now people have financial damage. Some people may lose their house. Some people may have to, after being downsized, they may have to go on COBRA for their insurance, not be able to pay it, and find out they have cancer.
Yeah.
It's very serious, and we frequently act in this industry like it's not. That doesn't mean you should have a panic attack, over bugs, because that's not productive, but it does mean that you shouldn't just let them slide either, especially bugs that impact revenue.
So the second one that Will has listed here is that they will have to switch out the database from under an application.
And I hear developers talk about this a lot. That's the reason a lot of folks really like object relational mappers. It's really not a good reason to like object relational mappers. There are others, but the possibility that, hey, I can just switch out my data, my database out from underneath the application, that's not a good reason for an ORM. There's several reasons for this. One, it almost never happens. I've done it twice in my career to some degree. Neither time was a complete switch. Okay. It was actually switching part of the app out to a different database system, and it was for performance improvements. So it was still in the old. It just was copied to the new partially. Mm-hmm. So that's the first thing. Another thing is, if you do have to switch out the database underlying an application, there's going to be some level of rewrite. It just doesn't happen that there's not. You're going to have to completely retest the application. Things are going to change. But yet we hear developers and C developers act like that's something that actually happens, that you're transparently going to switch out the database. And that's just not really a thing. Finally, the other reason I really dislike this particular one is when you write code that generically works across different databases, what ends up happening is to make the code where that is still portable is you miss some of the best features of the database that you're using.
Well, it's kind of like the same thing that happens when you try to write apps cross-platform, especially across mobile platforms, is you end up writing a web page wrapped in an app.
Yes. Or you end up, with the lowest common denominator.
Yeah.
And that's what happens here, and that can really hurt performance and stability. I'll give you an example. Let's say that you're using SQL Server, because I've got a lot of background there. They have a data type that is 4 hierarchies. It's a hierarchy ID. Mm-hmm. So you can nest your objects or your records. You can say what the parent is, and you can query against it, right? Other database engines don't have that, or they have a different one, so you can't use it. Well, if you leave that out, what do you have to do now? You have to do nasty joins and a lot of very complex things to get something that's simple and built into the database engine. Same thing with table valued parameters. It's completely different calling notation when you're doing that in other systems. So it's better to get a little bit lower towards the database because you're probably not going to switch it out.
Well, I thought that was why you had the ORM, just so you didn't have to switch out the database. And
that's part of it. Yeah, I mean it's to abstract the database.
That's what I was thinking, was that you abstract the database out so you don't have to worry about going in and changing databases and changing all the code to go along with that. You just
and it can help.
Yeah.
But an ORM doesn't do a very good job of making it where you can switch databases transparently. That's not a thing, and it probably never will be.
Well, that's not what I'm saying. That's what my understanding of an ORM was, that you had it not to switch out the database, but to make changes to the app without having to make changes to the calls to the database that doesn't change.
Right. And it just makes it less painful.
Mm-hmm.
So a third thing that developers act as if they believe that isn't true is that specs cannot change while coding is going on. You'll look here in the notes. We ship out the show notes for this thing, or not the show notes, but the outline.
Yeah.
The first point under that is no.
Just to cut in here for just a moment. In order to get the outline, that is something special we send out to our mailing list subscribers. So go on to the website at www.completedeveloperpodcast.com and sign up for our mailing list, and you will get a complete set of the outline that we use every week before the show comes out.
So the idea that specifications can't change while coding is going on sounds really great on paper. It's not really true. Even NASA will change specs on things as they learn new things, as things change slightly. It's expected. They don't change as much because they plan like crazy for years beforehand.
Yeah. Well, it's probably just because I'm very new, but maybe my understanding of specs is not the same. So What are you meaning when you say what are they meaning when they say specs can't change?
Where data is stored, what the user interface looks like, how it communicates with other apps in the ecosystem that it's in, how it manages security. It's very frequent that I will work with developers that go forward with the idea that, well, we're already coding this, you can't change the spec.
Maybe it's because I've been listening to a lot of podcasts that are for new coders, and they're trying to teach us right. But there's a lot of stuff I would never have thought that, because from what the courses I've taken and the things that I've learned, it's you need to be ready for when this happens.
Yes, and that is the case, and all the courses say that, and nearly nobody does it, or does it well. It's painful to change. When you're halfway into something, and then, oh, hey, they changed it. Now you got to figure out which pieces of code to rip out, what to move, what you have to adjust, and you have to retest, and it is painful. It does have a cost, right? You should discourage, arbitrary change or unplanned, things that they could have planned that they didn't. Right? They need to be aware that there's a cost there.
From what I've heard, this is why it's good for a developer to be on the planning team.
Yes.
To be involved as early as possible, especially with like front-end development, working with designers. Company brings in a designer, the designer designs this beautiful, amazing website, and then they take it to the developer, and the developer's like, yeah, that's actually not possible.
Yep. Been there, done that.
Mm-hmm. And so, like I said, that's why just this one doesn't make sense to me, because it's everything I've heard in all the classes, the online courses, and things that I have taken say, you should be as involved as possible in the planning so that you don't have to change, but be ready to change when that happens.
Right. So the idea here is that just like NASA launches a rocket into space, you're launching an app into the economy and into the regulatory environment. Earth's atmosphere, the government's regulatory environment, and the financial systems change constantly. That's their defining feature. They're complex, chaotic systems. You cannot launch something out there and expect stuff not to change.
Next on the list is belief, or the acting as if your employers care about pedantic coding arguments. And this kind of goes back to our very first episode where we were talking about talking with non-developers, and we were talking with bosses that aren't coders, and when it comes to things like that, they really don't. It's not important to them. It may be important to you and other developers, but you have to realize that's not their world.
Right, and it's frequently a problem too when it is something that is actually important to them, but you don't express it in a way that sounds important.
Oh, that's a good point. I hadn't thought about that way.
That's very commonly, that's the reason we get so wound up over some of these things, where, okay, this app is structured in a way that makes it hard to make changes. There's a base class here, and everything derives from it, 10 levels deep. This is bad. Well, your manager probably doesn't care, because unless there's a financial cost to that, it just doesn't matter to him.
Coming from a different perspective, that's where I look at this and go, there is a financial cost to this. It's just not an immediate cost. It's a potential cost down the line that's going to be very high when somebody comes in to change this.
So one way that you can express this, and this is pretty common in tech, is the idea of technical debt. It's the idea that, okay, I'm taking from the future for now, which is what debt is.
Yeah.
That's somewhat a decent term, and it gets the idea across. However, if you want to get a little bit better into the financial world, especially if you're talking to CFOs and some of those kind of people who wield a lot of power that you probably want sometimes, this sort of thing, a better way to refer to it is that it is an unhedged call option.
So what's an unhedged call option?
Well, a call option is when the right, not the obligation, is sold to someone to buy an agreed upon quantity of something at a price that is fixed now. Like you say, okay, you're buying an option from me to buy corn at $1.99 a bushel.
Yeah.
For the next 6 months. It's fixed. You pay a small fee.
But you don't have to buy it.
Right. You don't have to buy it.
This is
okay. Now, what happens next is corn goes up to $3 a bushel. You say, I'm going to buy 100,000 bushels of corn from you. Corn just went up to $3 a bushel from $1.99 a bushel.
Okay.
$1 and a penny.
Mm-hmm.
It went up. How much money am I out? Okay, I don't possess the corn. I'm buying it, potentially. I don't have a hedge. I'm not prepared for it. Do you see what that does to you?
Yeah.
It's leverage.
Okay, that makes sense.
Right? So I think it was Archimedes. It was one of the Greek philosophers that said, give me a lever big enough and I can move the world. Give me enough leverage and I can destroy the financial market. So it's an unhedged call option because you don't know when that's going to happen. You'll see it coming, but you don't ever quite know when it's going to hit, and it will hit at the worst time in the worst way. It's important to think about the things that you're arguing over, whether it's actually important to the business or not, because when you too frequently argue and throw a hissy fit over little coding issues that really don't matter to the financial health of the business, when something comes up that does matter, they don't listen to you. You become the boy who cried wolf. The fifth thing that developers act as if it's true when it isn't is that new technology is necessarily always better.
Now, I'm an early adopter. I got Windows 10 as soon as it came out. I got the Raspberry Pi 2B as soon as it came out. And, if I had all the money in the world, I would probably have an iPhone 6 and Xbox One and all that stuff. But, I got to watch what I spend because I'm...
Got to eat.
Yeah.
And a lot of developers are very quick to jump on the bandwagon of the newest, greatest, hottest technology, especially when it's bleeding edge. And I refer to this practice as resume-driven development.
I can see where you're going with this.
Right, because it makes you look good. I started a project and 6 months ago, I did this huge project in, whiz-bang new JavaScript framework, 1.0, or actually 0.95, before it was released.
Yeah.
It looks good for you. However, it's also volatile. It's a risk. It's a risk to your employer, to you as well. Because remember, we talked about the financial problems of bugs.
Well, I think there's a difference between what is business-wise and what is career-wise in this particular case, because for your boss, for the company you work for, no, you shouldn't do that. But for yourself, yes, especially if, like me, you really love grabbing the newest thing and learning it and being the one that helps the mid and late adopters when they come along.
Right. So you can still leverage that. It's just that you start that project on your own stuff. You don't start bleeding edge things for the company. Now, the other thing that I see a lot of is developers saying older technology is not as good. Where I'm working right now, we have a .NET section and we have a Delphi section. There are two Delphi programmers there.
Yeah.
Now, could we do everything they do in Delphi and .NET at the same performance level? Probably eventually. But you're going to be writing some extremely nasty code to make that happen, because you have to deal with what happens if the garbage collector runs while I'm drawing, rendering a PDF. The newer technology in this particular case is not better, and that's frequently a thing you'll see, is everybody goes, oh, that technology's old. Look, if it's still supported and it still runs,
there's a reason that it's still supported, because it's still being used, because it still has a use.
Yes. The thing in technology is there's always a lot of buzz around the newest stuff, and so I especially encourage younger developers out there to be a little bit careful about this. As you get a little further along, you'll see stuff come out, and there's a huge amount of hype around it for 6 months, a year, 2 years, and then it just dies. And all the people that bought into it too early are just left holding the bag. And I remember Visual Basic web classes. We're talking late 90s. That was going to be the newest, coolest thing. It built up, and then poof, there's nothing.
I'm thinking from the gadget side of it, the Zune.
Yeah.
I had one.
Yeah, and so newer is not always better. Be very careful to evaluate things based on their strengths and what you can get out of it, not the new whiz-bang factor, because that will fade, and then you're left with something that may not be particularly maintainable.
Yeah, it's like a lot of things. The stuff that grabs your attention about something is not what makes it sustainable. It's what pulls you in, and when you get in, you see, is this sustainable or not?
Right.
And I'm assuming that over time, within the programming field, you learn what is and isn't sustainable. Well, you learn to determine that quicker and easier, just because, like I said, I had a Microsoft Zoom, and now I'm much better. I'm older, and I'm much better at looking at something new that comes out and go, there's a lot of hype around this, but I don't really see it lasting.
And you also have to bear in mind, a lot of critical infrastructure is written on really old technology.
So the reason it is because
they got it working, and there's no reason to screw around with it.
It's stable. I remember when I was working at the hospital, our registration system, like the system that we go into to put patients into the hospital and things like that, was Unix.
Oh yeah, old green screens.
Yeah,
they're still around.
Oh yeah,
and there's a reason for that. Is it still works?
It still works, and it was very stable, and they didn't have to worry about bugs and things. Because
we'll get into that here in a minute.
Yeah.
So, point number 6, or the 6th thing that developers do, is believing that a snapshot of data tells you everything you need to know about what's going on. And this is particularly insidious when you have systems where you're writing to a database, and then like you create a record, and then you change that record, and then you change it again, but there's no logging. And a lot of developers think that the app is done then. It reads and writes from a database. What more could you want? So I'll ask, would you be okay with it if when you went to the bank and you got your statement, it just showed how much was in your account? No transactions, and they are not retrievable.
No.
That wouldn't be okay with anybody. Some of your most valuable data that you can collect, and people miss this all the time, is the data as it's happening. Right? It's not the end product that's necessarily so important. Bear in mind, when you're collecting data for a system, you're building fountains, not statues. The movement, how it got from point A to the end, to point D or point Z or whatever, the steps in the middle matter too. They have a business value. They also have diagnostic value if something goes wrong. So it's very important to make sure that you have appropriate logging. That's a first-class citizen. It needs to happen from the outset.
It's like the similar to the Heisenberg uncertainty principle, that you can't know the location and the velocity of an electron at any given time.
It's kind of the same principle, right? Because you're saying, okay, I know where it is. That's great, but you don't know how it got there. That's fairly important, and it's a thing a lot of developers miss. If you bring this up in meetings, especially as a junior developer, and say, aren't the intermediate steps valuable? And there's something business actionable in those things, it will make you look a lot more perceptive, because there are a lot of senior developers that don't even get this.
The next thing that developers tend to believe that isn't exactly true is that the difficulty of scaling an application is linear.
Right, and this is hard for me to give good examples of, because there's a lot of technical detail that goes into this, but the things that work for optimizing a small application with a few users can work up to a certain point, and then it stops working because there's some other natural barrier. There's some asymptote that you get caught under, and you have to do something different.
Well, it seems to me like it's more of a logarithmic function.
Yeah, or there's various ways to look at it, and math isn't necessarily the most helpful way. So let me bring in an example from biology. You'll recall from biology in your childhood, probably at some point, that somebody told you that ants can lift 50 times their body weight. right? And it probably varies based on the ant, because there's some pretty nasty little ants in the Amazon that I don't really think anybody's going to stick around long enough to measure how much they can lift versus their weight.
I always wanted to find those yellow ants that cure cancer.
So an ant can lift 50 times its body weight. That's still no big deal. An ant is very small. If an ant's body were scaled up to our size, its own body weight would break its own legs. Scale is extremely important. Just to give you an idea of just how much that matters, go, and I'm not going to do this on here, but this is an exercise for the listeners. Go and find out how many people hit Google's homepage every day. Now,
it's probably about a Google.
It's a
Sorry.
It's a metric crap ton, which is bigger than a standard crap ton, just so you know. Right? So that many, this humongous number of people hit Google's homepage. If you have a CSS class on that page and you're able to take out 2 bytes, the length of it, so instead of it being called logo, you call it LG, right? You got rid of 2 bytes.
Mm-hmm.
Okay. Let's say that Google gets, let's say they get 1 billion hits in a day. Okay. That 2 bytes is 2 gigabytes of network traffic. Think about the electrical impact. How much power you just saved transmitting that back and forth. It's, things get weird at scale. And when they scale up again, they get weirder.
Mm-hmm.
So it's very important to remember that scaling an application is linear until it isn't. Okay, here's another biological example, right? If you have a very small animal, being warm-blooded is helpful to keep it from freezing to death in certain environments, right? But if you scale that same mouse or whatever up to a dinosaur's size, suddenly it has an internal heat problem because of all of its biological processes going on in the insulated interior.
Mm-hmm.
Scale does this. So it's very important, and developers tend to miss this, especially in the early planning stages, because a lot of real tight optimizations that work at the small level are absolutely horrible at the larger level.
Yeah, I've seen this just with CSS. Some things that would work for the particular HTML page I was using, and I was wanting to use that same style sheet across, did not scale up.
Yeah. The other thing that I see a lot of, that developers act as if they believe, even though it's not typically true, is that a project rewrite is typically a good idea. You'll hear this all the time. Well, if we could just rewrite it. Folks, you can't. Most of the time, a rewrite is a really bad idea. There's been a few browsers in the past, one in particular, that you probably don't see around anymore. Think which one?
Netscape?
Yep. Good old Netscape. Do you know why you don't see it around anymore?
Because Chrome's better.
Well, Chrome's better, Firefox is better, IE is better,
Mm-hmm.
Lynx is better for that.
Weren't they charging for Netscape or something?
They were for a while, but that's not what got them. If I recall correctly, and I could be wrong on this, what they ended up doing, though, they said that, hey, this project has too much technical debt. It's too hard to maintain. It's big. It's tightly coupled. It just makes programmers cry to deal with. Let's rewrite it. Okay? What they ended up doing is they put a team together. They started a rewrite. They did not continue maintaining the branch they had.
Now, that's the problem. If they had done the rewrite and maintained, like, 2 teams or something.
Right, but then any fixes in one branch suddenly aren't in the other. There's a whole other level of management. Remember the thing we talked about with scale? It also happens with development team size. That doesn't scale linearly either. If you have 2 developers on a team, it's real easy to get stuff together. If you have 10 developers on a team, it is not 5 times as hard as having 2. It's more like 20 times.
That's why we have so many different version control things and like Git.
That's why we have Scrum, we have Agile, we have Kanban boards. We have all these tools built around the fact that we don't scale. things at all very well. And when you do that, you have to have more tooling. You have to have a lot more tooling. You have to have a whole lot more people. So what they did is they essentially said, hey, we're going to make another, a brand new updated version of this thing. And they didn't pull it off, and they died. And it's actually pretty dangerous for a software company to go, hey, we're going to do a ground-up rewrite. Because several things happen. One, okay, yeah, maybe you fix the bugs that are in the old system, and you fix all these problems that are internal to the software. But what you don't do, most of the time, is you don't prevent new bugs from entering. Because you're now under a time crunch.
You also have the problem with backward compatibility if you're doing it from the ground up.
Right. You look at it and you go, why is this if statement here? And it turns out that there used to be a large community of people using your software that had one particular problem with one particular thing. And some developer 20 years ago or whenever put this in and it fixes the problem. But you don't take it over because you're like, I can't see why that would be a big deal. And there's one guy that's still doing that. You just broke it for him. It's essentially when you say, I'm going to rewrite this software and get it, to clean it up and make it do what our current one does without, any enhancements or anything. You're essentially saying, I'm going to run as fast as I can for 6 months to stay exactly where I am. Your competitors, however, are running as fast as they can to get ahead of you.
Yeah, I mean, that makes sense as to why Microsoft came out with Edge instead of rewriting IE.
Yeah. Well, Microsoft also had a brand problem with IE.
Yeah, they do have a brand problem with IE. And then they had the issue of Windows 8, which I won't get into, but
yeah. Well, every other major release from Microsoft is crap.
Yeah,
it's that seems to be the cadence, and it sounds really bad, but it's more the thing of they try something brand new, and they throw it out there and see if it works, and some things do work and they stick, but they get a little I would say heroic. They get adventurous with their new releases,
yeah,
and then they get burned and they fix it in the next one,
mm-hmm.
and then they get adventurous again because hey, it's been a while.
Well, that I like that in that they're innovative.
Yeah, it's punctuated equilibrium is what it is.
But, of course, I've also heard from people at Microsoft that 10 is... Wasn't there the big ordeal about the guy that said 10 is the last release that Windows is going to have because from now on it's just going to be...
evergreen.
Yeah.
And maybe they'll do it. But the point is Microsoft has not rewritten Windows from the ground up. Now, that said, they've patched the daylights out of it. They've fixed smaller subsystems over time. They've cleaned up the code base. You can't fix the whole thing. They could not do a ground-up rewrite. They would lose all of their clients, and they'd spend billions trying to get the thing out the door, get it tested,
It seems like it'd almost be wiser to come out with another product.
Another operating system?
Maybe
based on Linux?
Yeah.
They have one internally, by the way.
Yeah, I had heard that. I wasn't...
Yeah, and they've essentially built on another core, but they're keeping their other thing going. But this is Microsoft, right? These guys have got a lot of money. You can, another thing about scale is when you have enough money to throw at something, it makes scaling a lot easier.
Well, it changes the dynamic, too.
Yeah. Whereas a smaller company, which is what most people work at, even if it's a Fortune 500 company, massive system rewrites are very expensive and very dangerous. It's a good way to lose data. It's a good way to break the entire system. And frequently it's a good way to throw a whole lot of money away and get something that is maybe not even as good as what you had before. And that the people that were looking at the previous system, they don't understand why you spent so much to give them exactly what they already had. And finally, the ninth point, and this will be the last one, is that software developers frequently act as if good relations with people from other departments don't matter. So, hey, that guy, I see this all the time, and part of it's the social awkwardness that a lot of developers have, and part of it is a bit of kind of snooty disdain for other people. I see this most frequently between developers and sales guys. Because the sales guys, they're all sociable and they're extroverted and they're all happy and optimistic about life. And developers have a tendency not to be, because a problem is a real problem. It's not an opportunity for growth.
I can tell you something about those salespeople, being one myself, and working with them. They're not like that. They put on that front because
it makes sales.
It makes sales. That's what they have to do.
Yeah, it's an effective way of approaching what they're trying to get done. It's an effective mental state to be in. Just like a developer being pessimistic is actually a fairly effective mental state, because you have to think of everything that goes wrong. A good salesman walks across the street and doesn't even look. A good developer looks both ways on a one-way street. Because the focus for the salesperson is on what can go right. How can I make it go right? The focus on the developer is how can I keep it from going wrong? Yeah, there's frequently a very snooty attitude towards salespeople, and it's exacerbated when salespeople frequently sell things to clients and they aren't sure whether those things can work.
They can make promises that really can't be kept.
Right, and it's very easy for them to do. But the problem comes in when developers start treating those people as if they are creating a problem. And this person's not creating a problem. They're trying to create a paycheck for you. What you should be doing is you should be engaging with those people. Go to lunch with them. Learn how they sell things. Learn what their process is. Talk back and forth. Because what you really want to do is you want to open a dialogue. Even if your organizational structure is, the salespeople don't talk to the developers, they're not going to get after you if you go to lunch together because you're friends. We need to have an episode about misconceptions developers have about sales and how that works and how a sales cycle works, because I think that could really reduce a lot of pain, because developers typically have not been involved in the sales cycle. And so that not knowing tends to make us believe things that aren't particularly true. And it can help you sympathize a lot when you understand what that sales guy is going through.
Yeah, that's really good, because I've actually been working on an episode specifically for that. And I should be able to have it ready by next week. So next week we will be talking about how to interact with salespeople and how to understand them.
Cool. I guess that's proof I haven't looked at the Kanban board enough. I didn't know that was coming, but it's good that that's going to be a thing, because I think that would really help, and maybe we need to do similar things for other things. We talked about how to talk to bosses.
Yeah, well, this is what I'm working on. Isn't so much a how to talk to salespeople, because
it's how to understand them.
Yeah, it's how to work with them and know what they do and how that affects what you do, and how to explain to them how what you do affects what they do, and the importance of them understanding what you do can make what they do better.
Right.
If I own a company and a salesman comes in and is trying to sell me a piece of software that he doesn't really understand, I'm less likely to buy it from him. Whereas even if he doesn't know much about the inner workings of the software, but if he can say, this is the features, this is what it does, this is what we're working on to bring out in the future, then I'm more likely to seriously consider buying that software.
Okay. I'm looking forward to that episode. That'll definitely be good.
All right, Will, what do you have for us this week?
Well, this week I've got a Chrome plugin I think that some of you will find pretty helpful. It's called Palette for Chrome, and it will allow you to create a color palette like you would use for picking out website colors from an image.
That's awesome.
So, if you've got like they show one on the background here that's a picture of the ocean, and you can actually build a color palette from this. It's available in the Chrome store, so it's got this awful long URL. We'll link it in the show notes, but the easy way to find it is Palette for Chrome, and it's available. It's offered by Unindented. That's like an indent, unindented.org, and I think it's pretty cool, pretty useful.
So is something that you could take like a very colorful background picture and
You can make a color palette, or if you have your company logo, instead of having to manually go in there and open up GIMP and zoom in and try to do the color picker tool and figure out each of those things and then get it wrong like I do every single time, you've got a plugin now that'll get that for you.
I got to say, that's one thing I love about the logo we got for the podcast is they sent us the hex codes for the colors.
Yeah. And if somebody's unwilling to pay large amounts of money, like $20 like we did, they may want to use this tool, right?
Yeah.
Because If you have a question or comment for us, please email us at neckbeards@completedeveloperpodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed under Creative Commons. The intro music for IoTs is OMFG Hello by Argo Fox and is also licensed under Creative Commons and available on SoundCloud. For references, show notes, and to sign up to our email list, be sure and check out the website at www.completedeveloperpodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Thanks for listening. See you next time.